This presentation describes a new symmetry hidden within distortions of matter and form. What exactly is symmetry? It is when doing something looks like doing nothing. For example, when you turn the square by 90 degrees, it looks the same. It is also called a four-fold rotation. Similarly, there are two sets of mirror symmetries, and the symmetry group of this square is 4mm. In this example of a yin-yang symbol, rotating by 180 degrees changes the image. If we now switch the black and white colors as indicated by the star operation, the image returns to its original form. The star operation is called the anti-symmetry operation. The symmetry group of the symbol is therefore 2 star. Now, instead of static images, consider a movie of a circle rolling from left to right. 9 intermediate frames are shown along with red arrows indicating the direction of motion. So what is the symmetry of this movie? Clearly, we need to do something that looks like doing nothing. What should we do? In order to answer this question, we introduce a simple new symmetry operation, the star, that reverses the direction of motion of the circle, which now rolls from right to left. As a consequence, the red arrows switch to blue arrows. We call this new symmetry as distortion reversal symmetry. With this new symmetry operation in hand, let's find out what the symmetry of this movie is. We note that a mirror symmetry in the middle flips the frames and brings the set of circles into self-congruence. However, now the blue arrows have turned red, which looks different. If we now perform the star operation, the arrows switch back from red to blue, and the movie returns to its original state. So the symmetry of this movie is M star. So how is this symmetry useful? Consider an oxygen atom diffusing across the surface of graphene that is made up of hexagonal rings of carbon atoms. Which path would the oxygen take in moving from left to right? The straight oxygen path across the carbon ring has a unique path symmetry of M star M2 star. However, this path has a high energy barrier. This path with M star M2 star symmetry goes over an energy hill. Can we shake up this path to find a better path with lower energy? It turns out that there are only 3 possible unique ways to perturb or shake up the M star M2 star path. These are shown in the red oval. A perturbation of the path leads to a new path with M star symmetry, where oxygen goes around the carbon ring instead of across it. The overall energy is significantly lower for the M star path as compared with the straight line path. Thus, using the distortion reversal symmetry approach, we have found a path of least resistance for the oxygen diffusion on graphene. Using the distortion reversal symmetry groups, one can predict how any property of a material may change under a distortion. Since distortions are ubiquitous, it is applicable to a wide range of materials and technologies ranging from structural and healthcare to electronics and communications. For more information, you can read Anti-Symmetry of Distortions in the journal Nature Communications in its November 2015 issue.